So before we get into the calculus lessons proper, let's just start with this general question here. What is calculus? Now, if you're the kind of person who likes to take notes, you don't really need to take notes on this, but we're just going to sort of discuss in general, what are we going to be looking at over the next couple of months? So what is calculus? Well, calculus is a branch of mathematics, and it's the branch of mathematics that kind of all of the stuff that you've been doing in grade 12, grade 11, kind of starting around sort of halfway through grade 10 has sort of been leading up to. It's a way of mathematically describing systems that are continuously changing. And we've looked at systems before where we've got change from one point to another point, and we looked a lot at that when we were doing our vector stuff. Something moves from here to here, we used a vector to represent how it got from point A to point B. In calculus, we are looking at continuous change, okay? And the big advantage of understanding calculus is it allows us to mathematically model systems that are more complex or sort of less regular than the systems that we can with the algebra that we've been looking at up till now. So just an example here of calculating the volumes of shapes. You've done this for years and years in math classes. You've looked at these specific shapes and said, okay, I know the formula for calculating a sphere. I know the formula for calculating the volume of a cylinder. I know the formula for calculating the volume of a pyramid, as long as your shape was fit into one of these nice defined little categories: pyramid, cone, cylinder, whatever. What if you had a shape that looked kind of like this, that was this irregular shape, and you wanted to find the volume of it? Well, as long as you can define the outside surface of this shape using a function, you could use calculus to figure out what the volume of it. So it doesn't have to be a nice, regular, rigidly defined shape. It can be anything that we can describe using a function. And that's why we spent so much time up until now working with functions, because they kind of form one of the things that we need to use when we are doing calculus. So there are two big branches of calculus. There is a branch that is concerned with how quickly something is changing, or looking at rates of change. Okay? And then there's another branch that kind of looks at accumulation. So to give you specific examples here, let's say you've got water leaking out of the water tank in your basement. One branch of calculus might ask the question, well, how fast is this water leaking at this very instant? Whereas the other branch of calculus might say, okay, if it's been leaking since 3 a.m. and I know how fast it's been leaking at each instant, how much has sort of dripped into my basement over the course of those few hours? These two branches are called differential calculus and integral calculus. Okay? If we're looking at rates of change, we're probably dealing with differential calculus. Okay? And if we're looking for the amount of stuff that has accumulated, we're probably looking at integral calculus. We only cover one branch. We'll do differential calculus in this course, and you won't see integral calculus until you get to university. Both of these branches have kind of a graphical interpretation of them. If we are doing differential calculus, what we are looking for graphically is we are looking at the slope of a tangent. Okay? And that's the problem that we are going to be working on over the next few months, is finding the slopes of tangents. And we're going to talk more in a couple of lessons about what exactly we mean by slopes of tangents and why they're important. Okay? If we were doing integral calculus and we had some curve, we would be looking at trying to find the amount of area underneath the curve, or the amount of area between a curve and an axis, or between two curves. So one, we're looking at really lines here. The other one, we're trying to find areas. So as I said, we are going to look at differential calculus. And it's going to be all about finding rates of change, or another way of saying it, how do I find the slope of a tangent to a curve at some given point? So in order to do this, we are going to need to learn a couple of things. We're going to need to learn what limits are. Okay? And we're going to cover those on Wednesday. We're going to need to take a look at what a derivative is. And derivatives are going to be the mathematical tool that help us to find these slopes of tangents that we're looking for. And then we're going to broaden it and look at some applications. What can these derivatives that we found tell us about the graph of a function? How can we use derivatives to solve a bunch of different problems that come up frequently in mathematics? Okay? So that's differential calculus, and that's kind of where we're going to be going over the next few months.